Hi, it's Mr. Adams from Midway High School, and this is a video on Table J activity series. Table J simply shows us the activity of metals and tells us that as we go higher on it, okay, we are more easily able to oxidize these metals. Now, metals in general tend to lose electrons to form positive ions to become more stable, right? So these guys that are higher up here are more able to lose electrons and cause something else to be reduced. Okay, so these guys at the top of the table are more easily oxidized and are better reducing agents. It's very important that we know that solid metals, okay, will reduce any aqueous metal ions that are below it spontaneously. And for our purposes, spontaneously simply means that it can happen naturally without any continued outside influence. In class, we did this demonstration where we had a piece of solid metal, ALS, solid, okay, and anything solid in terms of metal or a single element will be in a zero oxidation state. And we put it in a solution of copper chloride where we had copper ions floating around, okay, in the aqueous phase. And as we saw what eventually happened, we saw the formation of copper solid, Cu0. So if you notice, the copper is going from 2 plus to 0, right? So that copper ions in solution got reduced. And on the flip side, Al went from Al0 to Al3 plus in solution. So we can see that the Al got oxidized. Okay, so if we look on our table J over here and we find Al right here, right? Al in the solid phase, okay, is higher than copper when it was in the aqueous phase. Okay, so Al was solid and copper was aqueous. This reaction will take place naturally and spontaneously. On the flip side of that, we did another demonstration where we put solid copper, Cu0 right here. Okay, we put it into Al3 plus aqueous, right? And we saw that there was no reaction. Now, once again, if we have Al3 plus and it's aqueous, Aq, all right, and the copper solid is all the way down here, the solid is not above the aqueous, so that will not take place. Okay, that will be a non-spontaneous reaction. All right, so we're moving on. Now, another example, what we have here in the bottom, we have copper solid in the zero oxidation state. That's going to be reacting with AgNO3. Now, folks, anytime you see a compound, ionic compound, reacting with a metal, and it's asking about single replacement, you can automatically assume that that ionic compound is in aqueous phase. Because if you're trying to do it a single replacement, 99% of the time, and you're using a solid metal, you need some type of aqueous solution. Okay, and this reaction takes place because if we overlook here carefully, the copper solid is above the Ag aqueous. Okay, so this reaction will also take place spontaneously. So once again, if your if your metal solid is above your aqueous ions, you get a spontaneous reaction. Okay, we can use table J also in relation to acids and metals. All right, once again, the same rule applies. If your solid metal, for example, magnesium, is above the acid, okay, the reaction will take place in a single replacement fashion and release hydrogen for you. Okay. Now the thing is, on table J, what's going to happen is this is not table J. This is what we have in our reference table. This is a bit of an expanded form of it. Our H plus, right, will be represented by H2 right here. Now this is what happens to H2 when it oxidizes. It gives you 2 H pluses and releases 2 electrons. Okay, so that's why we use H2 to represent our H plus. Now our magnesium solid, okay, right here is way above the hydrogen. Okay, our positive ion in aqueous solution. The reaction will take place spontaneously. Okay, so they give you metals with acid, that's all you have to do. Now, these guys below here, right? Okay, they won't happen spontaneously to produce hydrogen gas for you. Why? Because they're solid metals and they're below the aqueous. But a word of warning over here, copper is affected by acids, right? But not in a conventional way. It's the non-metal part of the polyatomic iron part, or the non-metal part of the acid, reacts with copper metal, not the H, but the other part of it. So that's a reaction we'll talk about later, and you typically deal with in AP Chem in college when you move on. But for our purposes, we're mainly interested in H plus and how it interacts with the metal. So once again, if you're above, okay, H2 and you're a metal, you will do a single replacement reaction and you will cause hydrogen gas to be formed. If you're below, okay, H2, the reaction will not be spontaneous in terms of producing hydrogen gas. All right, and lastly, table J helps us determine the anode from the cathode in voltaic cells. We'll talk about voltaic cells tomorrow, and it's a simple, nice memory device. Anox, okay, and red cat. Now, what does that mean? Anox simply means that the anode oxidation takes place, hence the name anox. And at the cathode, cat, okay, reduction takes place, red cat. All right, now once again, what's an anode, what's a cathode? We will talk about that later in a future video and in class. Okay, so as always, hard work plus sacrifice equals success. Please study, please study. We have a quiz this week. The test is coming up on Wednesday, and take care.